understand, because what we're going to discuss in this talk today is primarily about in our organization in PokerBaazi, when I'm working. So how did we manage to implement chaos engineering and see the results after it? Because when we are talking about an online gaming platform which is serving over 1 million players, and in that scenario, when you have real-time money, RNG, it's RNG, real money gaming platform. So when you have that platform in hand, you have to be very critical and you have to make sure that a slightest bit of change can damage everything. So that is why that is very important. So I think it's a good time to start now. So a quick introduction about myself. My name is Siddharth Vijay. As she already mentioned about me, I have close to 12 years experience in the industry. My core niche is DevOps, cloud, cybersecurity, but in the last 5-6 years I've been very deeply involved in backend engineering, platform engineering, databases, QA, etc., etc. So I had on multiple hats at PokerBaazi where I'm working right now. I joined PokerBaazi about 4.5 years back, and now I'm leading multiple verticals over there, wherein it's all mentioned on the slide, but like I mentioned about mainly I'm heading the cloud, DevOps and cybersecurity division. So after a decade of working in the industry, I realized that I've gained a lot of experience, I've learned so much, so it's time for me to go back and give it to the community. And that is why from the last couple of years I've been extensively doing conferences, giving speeches and talks, workshops, seminars in India and abroad, everywhere, wherever I get a chance. Wherever I get a chance to talk about DevOps, what DevOps has brought into the market, what DevOps has brought into the industry, I do that, and hence I am here. It was a very far-sighted approach for me to come to DmCon, but I'm really glad and thanks to the organizers for giving me this opportunity. Cool. So let's quickly start with the topic since we have just 20-25 minutes. What is chaos engineering? Anyone? Any idea? Couple of hands. Have you heard about chaos engineering before? Do you know it is a part of our DevOps family tree? Because DevOps has a family tree now. It is not just DevOps. It has multiple branches and it's going on and on. I mean, you have DevSecOps, and then you have platform engineering, you have SRE, infrastructure engineering, etc., etc. So in that family tree, somewhere down there is chaos engineering, is what we're going to talk about today. Okay, so I believe all of you have some relation with DevOps. Someone who doesn't understand what DevOps is should not be here, ideally, but still asking. So anyone who has spent hours and days debugging a prod issue and just not getting the root cause behind it? I believe all of us have done that multiple times, right? Anyone who has, by mistake, broken something in production? Just one guy? I'm also there. So some of us, most of us, right? So now if we do this intentionally, we all will be certified chaos engineers. This is what chaos engineering is about. Whatever you have done unintentionally, by mistake, human error, or whatever you call it, and something has been broken in production, which has affected your services, your application, your runtime, your infrastructure, just think of that same scenario. Try to do it by yourself in a very controlled environment, obviously, wherein you don't want something else to break as well. And when you do that process, you are doing chaos engineering. Simple. This is what chaos engineering is all about. We're going to talk about these 4 or 5 pointers today, very quickly, to understand where it all began and how can it be useful to you. Cool? Alright. Have you guys heard this proverb, curiosity kills the cat? All of you must have heard about it. We read it way back in school, right? By the way, I didn't take and leverage AI to make this PPT. It is all my own manual handwork. Okay? So in this age of AI, I wanted to do something personally. So this PPT, which is not very great, so don't judge me by my presentation, judge me by my talk. Cool. So curiosity killed the cat. This is a very famous proverb. What does it say? Do not try to intervene into something unnecessarily, which might or which can impact or hamper or harm you, which makes no sense, right? But if you ask me, in today's world, curiosity killed that. See the fancy S bouncing on? So that curiosity is killing the cat. Who's the cat? We are the cat. How is it killing the cat? See, it is very important as DevOps engineers or infrastructure engineers or SRE, whatever you want to call it. It is very important for you to know that if something is going into your production environment through your own hands, manually, automation, CI/CD, whatever it is, you should know its and bits of it inside out. So that if something breaks in production tomorrow, you should know where do you have to look at. Because the developer who has developed that particular service or application will very easily come to you and say, hey, you have deployed the application, right? You know the infra better than me. This is not an application error, you should debug it on your own end. This is a very common discussion which happens, that this is not something which has failed from the application side. It must be something with your deployment or with your infra, etc., etc. Now in order or to have that discussion with the developer, you should very well understand that if this application is running smoothly in production, do I know everything about it inside out? If tomorrow this application starts giving 4xx, 5xx, latencies, throughput, etc., do I know where do I have to look at? Because the chain is very long. It is not just one single application. It starts from the development area. Then when you deploy a particular service in production, there will be a database involved. There will be some load balancers involved. There will be some EC2 machines or Fargate or ECS Kubernetes containers involved. There could be some third-party applications either consuming or feeding data to this particular service, and etc., etc. So to figure out which particular point do we have to look at to fix the problem, it is very important that you intentionally understand, put the efforts to understand that how is this application working. And that is where curiosity comes into the picture. I mean, for now you can do it by choice, but trust me, later on it will become the need of the hour for you to understand that if someone is coming to you and asking you about the process of your deployment of your application, as well as how does it interconnect with multiple other services, and if God forbid something fails in production, how are you going to fix it? You should be prepared for it. Now most of you might think that because I've done the deployment and I know what all factors come in the process, how big is it a deal if something breaks, I can easily go and fix it. Trust me, with 10 applications you can do that. With 50 applications you can do that. But when you cross 100 applications running in production over 100 Kubernetes clusters, right, terabytes of database, multiple load balancers, multiple secret managers, credentials, etc., it is not that easy to figure out. And we'll come to that. By the end of this slide, we'll talk about some case studies that we implemented at our own infra. And I was really surprised because, I had built that infra by myself from my own hands in the last 4.5 years. And still, when something breaks, it might take you a while to figure out and connect the dots. Because there's so much happening all across the infrastructure. There's so many deployments, there's so many applications that more often than not, either you miss out on something or you can't just relate to the initial part of it. Cool. Moving on. Okay. The need for chaos engineering. So we are anyways talking about that, but let's also look at a very fascinating and a very pretty picture. Nice, no? So we all saw this, what happened last week, I guess. Thank God it didn't happen last Friday, yesterday. So I was trying to Kochi from Delhi. Otherwise I would have been giving this talk virtually. So yeah, no offense to CrowdStrike or Microsoft or anyone. Those guys are our brothers. We should pray for them. We should help them in any which manner. There is no point blaming anyone because we all understand that shit happens. Things like these happen. But why did I add this slide in need for chaos engineering? I mean, I'm sure people at CrowdStrike and Microsoft must have everything in place to make sure such blunders doesn't happen, but it still happened. So you see, this is what I'm trying to tell you. No matter how much you prepare yourself, no matter how expert you are about your infra, no matter how many tools you have in place to give you the slightest latency alarm as well, even then things can go wrong. So you can never be prepared. Like in cybersecurity we say that security in cloud is a myth, right? It is true. Because no matter how much you say that, hey, in my knowledge, my cloud is secure, my app is secure, there's someone sitting in some random corner of the globe waiting for you to say that, and bang, one click and you're crying. So this is what happens if you generally do not facilitate the process to understand that if something goes wrong in production, which is inevitable, you can never stop that. You can never stop that from happening. But the idea is, the good part is that if something is broken in production, how soon can you fix it? And how will you do that? If you know where the problem is. Generally, you might have seen that it takes us days to create a RCA for a problem, not the fix, the RCA for the problem. The fix can be create a new server, kill the container, create a new container, right? Redirect the service to another load balancer, change the database setup, or change the asset credential, or etc. etc. The fix could be anything because cloud gives us the leverage to very easily spin up new servers, instances, in databases, etc. etc. wherein you have replicas of your similar setup running, kind of DR strategy you can call it, so that at that point of time you have fixed the issue. But when you are asked to create an RCA, it takes you days to figure out, can someone tell me what exactly went wrong? And this is where the devs and the DevOps engineers and the SRE guys and security guys and whatnot are sitting together banging their head that who was at fault? Where did we miss it? Was it the QA team who missed the very easy bug that could have been identified? Was it something at the DevOps end? Was it initially something at the dev end which could have been fixed with the dev testing itself? And the cycle goes on. So this is what the need is for chaos engineering. Moving on. Why chaos engineering isn't crazy? So the topic for today's talk, let's see what do we have here. Okay, failing to plan is planning to fail. I took the liberty of creating very fancy PPT which we used to do back in our college days with crazy images and animations because I think it's more about discussing and talking rather than writing something on the slide. So I guess this image should work. Alright, failing to plan is planning to fail. Very simple. If you cannot plan something which will happen for sure, you are pushing yourself to the area where you will eventually fail. That process of not doing something is taking it to a step closer to your failure. Why? Again, let's take an example. Let's say you are deploying something in production. Okay, you know that at one point of time, there will be peak traffic coming in on your servers and you have to either upscale them or whatever, horizontally, vertically, depends on your application, or you have to make sure that you manually focus on that area to see what is the scale that you are expecting. Now this is something wherein you know that if my servers are going to break at a peak time and if I don't scale them in any which way, I will start seeing 4xx, 5xx, etc. latencies, whatnot. This is something that you plan in a very happy scenario. Now comes the bad scenario, something that you are not even thinking about. The peak load came, thankfully and surprisingly, your servers ran smoothly, but then something happened on the database. There could be a query that created a deadlock on the database, and because of that, the server started throwing 5xx. There could be a problematic response on the database wherein the query optimization was not done correctly, or maybe, let's say, even if you're using NoSQL, there could be a problem wherein the over-provisioning happened because of the load and your bill started shooting from 50K to 150K. That is also a problem as a DevOps engineer which you have to look after in terms of costing. So this is where we talk about that if you plan to do something, if you focus on all those issues that you are not even thinking about which can happen in production, is where you are taking that step ahead so that if something fails in production, you know how to recover. You are mitigating and minimizing the occurrences of those instances which will eventually which will take you and land you at a place where you have no answers and you cannot even give an ETA to fix that issue. So that is why when something gets deployed in production, as a DevOps engineer, I personally always say that it's not important that you understand the coding languages. It's not important that you understand the coding frameworks, but it is very important that you understand the journey of that application and how it is being deployed. What are the core critical key components of that application, which once deployed into production can hamper the entire infrastructure scenario. That is why it is very important to make sure that one application, 100 applications or hundreds of applications, doesn't matter, it should go through a process where you understand the entire journey so that you can plan for such scenarios, otherwise it will eventually land into failures. Alright? Cool. Let's move cross engineering. It looks a very fancy word, but how do we actually do it? What is the process of implementing chaos engineering? Cool. So the first thing is identify hypothesis. Determine what you expect to happen. So this is what is exactly that we all want that our application should run properly in production 24/7, end of story. Nothing else is that what we need from it, right? But this is where you determine as an experimental hypothesis that when something is happening in production, I expect that application to give me these error codes if possible, or I should get good 200s everywhere. The starts should look good, the latencies should look good, the throughput should be at its best, and that is what is needed. This is what you define before you start an experiment. Design experiments, create experiments to test your hypothesis. Design your own experiments. Now this is where we are talking about, you have to manually, when I say manually basically, you have to think through it that I want to perform these steps and see what happens. This is something which we will never do in production. This is something which we will never want to happen in production. But no, we will do this intentionally in production so that if it happens in the future, we know what to expect and how to fix it. Execute experiments. Run the experiments in a controlled manner. Note that, please. Controlled manner is very important, because you would never want that an experiment that you have run as part of chaos engineering production did not break something which was intentional, but eventually it broke something which was out of your scope and you see a downtime. Now that is something which is out of the scope of chaos engineering. That is chaos engineering of chaos engineering. I mean, you are performing chaos engineering, but it reprocessed the chaos engineering and broke something in production which was not planned. So always do that in a controlled manner. I'll tell you how we did it the same. Analyze results, measure the outcomes and learn from them. What do you learn from these results? Okay, one random question. How important are matrices and logs for us? Good, very, very important. Anything? Very important. Right? Matrices and logs are very important. I mean, we feed on that data to take a lot of decisions, right? The system feeds on that data to do a lot of decisions. When we talk about AI is feeding, a lot of tools, monitoring tools in the market today says that our entire system is AI based. What do they mean by AI based? Because their systems are consuming our matrices, logs, etc., to then process that same data and tell us that this should be your ideal server size, this should be your ideal throughput. This is what you should be running as your application work environment or a runtime environment, right? So it is very important to understand that data which is being generated. Similarly, when you run a chaos engineering experiment, it is very important for you to understand the outcome of that experiment. There could be scenarios where something happened, but it was not worth it. But there could be scenarios where something happened which took you to a different tangent altogether, and now this is where you are connecting the dots. One service can impact another service which you can't even think of. But it does happen in production. Has it happened with anyone of you in production? Something was deployed and something else was not working out? What happens? A lot of time. Improve and iterate, make improvements and repeat the process. Repeat only if it is helping you. Trust me, it will. But again, repeat in a controlled environment. Do not just randomly run chaos engineering experiments in production. Why am I saying production again and again over here is because as per my knowledge and as per my experience, I've seen that no matter how much close you bring your non-prod or QA environments to production, there is something different about the production environment, which can never be replicated in non-prod or prod environments, right? Even if you bring in the same traffic, you bring in the same load, or you try to replicate each and everything as it is, but then production environment is dangerous. You cannot ever create the same scenario, create the same problem statement, whatever you do it, whatever automation you bring it, it can happen in production. That is why I am saying that when you run chaos engineering, always run it in production, but in a very controlled manner and in a very controlled environment. Do not break something in production tonight and curse me tomorrow, okay? I am not taking the liability for that. Cool. Let's move on. For some case study, and then we'll jump on to the actual case study that we worked upon. So chaos engineering, this term came into highlight way back, but actually the major element of it was implemented by Netflix in 2011. So in 2011, Netflix engineers were just trying to figure out that, so we have done everything, what do we do now? So let's break something in production and see what happens. And that is where they came out with chaos engineering, because they have so many engineers, they have so much automation. Most of the time they are sitting and idle, nothing to do. So they started breaking their own environments. Let's try and see what happens. So they did that, and that is when they created a tool called Chaos Monkey. So this tool was an accidental tool that got created while they were doing chaos engineering, which they didn't even know is chaos engineering. So they did something, it brought some output, they termed it as chaos engineering, and the tool, then eventually they made it into a tool with all the libraries and open source frameworks, and they called it Chaos Monkey. That is why I took the word monkey from Chaos Monkey, because every origin is from monkey. So chaos engineering origin is also from Chaos Monkey. So I chose monkey as part of my topic. Amazon has its own fault injector tool. I'm not sure if most of you are aware of not. It's a native Amazon service fault injector tool which you can use to inject fault in a particular service in a controlled environment, see the outcomes and work accordingly. LinkedIn is also performing the same thing in a different manner altogether. These are some very famous and very common tools: Chaos Monkey, Gremlin, Litmus Chaos, Cube Monkey, fault injection, like I mentioned. A very interesting anecdote: Gremlin over here introduced chaos engineering as FAS, F-A-A-S, failure as a service. So we all have heard of platform as a service, infrastructure as a service, DevOps as a service, software as a service. There is FAS also. So there is failure as a service. You want to have a failure? Come to us. We'll give you a service. Don't do anything manually. Take our service, bring in fault into your system, fix your system, be happy, go home. So that's what Gremlin is doing. In fact, Litmus Chaos has another very interesting part. So a couple of weeks back, I was doing an experiment on Litmus Chaos. So it's an open source tool. You install it on your Kubernetes cluster. You run a separate cluster for that, and then it gives you multiple options. So you can kill your container, you can fork the network of your container, you can increase the CPU memory, you can block the disk space, etc., etc. They have multiple options to perform as part of controlled chaos experiments for Kubernetes and for other services also. So a couple of weeks back, I was just going through that, performing some experiments on one of my clusters. I saw that they also have an option to run a chaos experiment on their own cluster. So I forked the network of a Litmus Chaos auth container which runs on a Kubernetes cluster, and the portal that I was using to log in crashed. So this is what you can do as part of chaos engineering, wherein you can see the immediate result of a particular auth container whose network has gone, and now you're not able to log in. Thankfully, they replaced that after 3 attempts of the time duration that you set for 60 seconds or 80 seconds, and that came back up again. So they even let you kill their own containers. Imagine the fun fact. I mean, you're using Litmus Chaos to do chaos engineering in one of your QA clusters, but instead of doing that, you're doing chaos engineering in Litmus Chaos QA cluster. So that's what the fun part is. Cool, this is that we implemented. This is the first case study. So I was very interested and very fascinated with chaos engineering, and I was reading about it, studying about it. I mentioned about I was using Litmus Chaos, I even tried Chaos Monkey. But I thought, before you leverage any of these tools, why don't you just try and do something manually on your own? And it's very simple, trust me. But then again, the repercussions could be deadly. So you take the call yourself. So what we did was, I created a random setup, which is a prod setup for us. In that prod setup, you see, so we have AWS service, we have an application, we have Lambda which is running, which connects to RDS proxy to connect to a MySQL database, and the credential of that RDS proxy is stored in a secret manager. Very simple, very basic setup. I ran that setup in production, I saw the stats and everything, I replicated it into a non-production, which is kind of a non-prod environment for me. I ran this test in a controlled environment with my team. What we did was, we manually deleted the SM credentials for that RDS proxy. Now what will happen? The Lambda function, not just one, multiple Lambda functions which were using that secret manager credential of the RDS proxy to connect to the main database started failing, obviously, because the SM credential is deleted. Will you ever do this in production intentionally? No, I don't think so. Someone can do it unintentionally by mistake, but you might never do this manually. In this scenario, if you talk about breaking something, what is the best option that you will do? You will see that maybe I'll change the security group of my database. Maybe I'll do something with my Lambda, I'll increase the Lambda proxies, etc. Maybe I'll delete the proxy altogether, etc. But we did something which was kind of very unique, which is very odd to do. We deleted the secret manager credentials. And to our surprise, we had already noted down a handful of Lambdas which would have been affected. But the number of Lambdas got affected was 3x of the number that we anticipated will go down. Why? Like I mentioned in the beginning of the talk, if you have 5 Lambdas, you might handle and you know the entire end-to-end connectivity. If you have 15 Lambdas, you have 50 Lambdas. When you have more than 150 Lambdas running in production, eventually after a period of time, you start losing the dots that are connected, and you might not even remember after a couple of years that where are these Lambda functions connected to the SM credential, because how often you go back to your old infra and take a rain check on it? We don't, because we are mostly working on new automation, new infra, right? This experiment told us that not just 15-20 Lambdas, it was almost 50 Lambdas that got affected in production. It started failing and giving errors because of removing one small secret manager credential, which is a very vague thing to do in production, or which you will never think of. Next one. Another example, Fargate cluster. You run Fargate for backend APIs. You have your service running, you have containers running. You inject a failure. Now in a Fargate cluster, we have multiple containers running. What is that one point where you think you can inject a failure? Anyone? I mean, which you think is the most probable option to happen by default? One of the containers can go down. All of your containers can go down. Right? The application can start giving some random errors. The Fargate cluster can start giving you random errors, right? So what we did was, we had manually set the auto scaling to 222, okay? And intentionally we started killing both the containers again and again. The containers come up, we kill them again. The containers come up, we kill them again. The containers come up, we kill them again. Why? Because when the containers were draining, the health checks were failing, right? When the new container comes up, it checks the health check, it is in healthy state, it will start accessing the service starts giving you a response. But when you don't let the container come up and you keep killing it, and this is the same thing which I experimented with Litmus Chaos also, wherein it kills the container and keeps doing it again and again for a specified number of seconds or minutes, whatever you set it up for, right? Now this process of continuously killing the containers, not letting them come up and the health check gets succeeded, your application will start giving you random multiple errors every here and there. I mean, obviously some of the basic errors are your application is not able to connect to the containers are not running, there could be 4xx, 5xx, etc., whatnot. But because the containers were again and again not getting up, you would start seeing latencies in your entire process. And there could be another application whose health check on a front-end page is dependent on the response of this particular API. Now this is something which you might not be interested in, or you might not even know, because a front-end engineer who has built the webpack or who has built the app has called these APIs as response checks to load the entire page. Now one service is failing, you think that, just 2 minutes, you think that this response is not coming, we'll immediately fix it by adding more containers. But on the website or on the application, there are other pages which are not loading because of this service which is failing, which has no direct connection from the backend integration. But there could be calls which are being called for some web pages and front-end pages to load, which consumes multiple API responses to work it out. So that in tandem, in totality, if you see, connect multiple dots together, but when you actually think about if there could be a random failure which can happen, I will immediately fix it. But in production, when such things happen, and if your team is telling you that such web pages or some app pages are not loading, you might take time to think about, connect the dots and come to this point. Now again, this was a very small experiment which I ran in production. Similarly, you can do multiple steps, and what I mentioned, you can use all those chaos engineering tools to perform those operations as well. Accordingly, whatever suits you to your requirement, which can tell you and which can help you out in understanding the overall flow and the process of your application. Cool? So this is what today, some of you might have heard this for the first time, for some of you it is very known. Then again, not taking the liability if you break something in production tomorrow, okay? Do it carefully, do it in a controlled manner, do it with your team, make sure you FYI everyone in the loop that hey, I'm trying and planning to run some experiment, which is for our own good, but make sure you run something, you know the repercussions, and the good part is you'll know a lot of things which you can't even think about. Cool? That is me, Siddharth Vijay, for today's talk. Thank you everyone for listening patiently. If you have any questions, if you want to talk and discuss about anything, I'm here right on the corner. Feel free to reach out to me. Thank you.